CSIR. Welcome, sir. I also welcome our esteemed speakers for today's session. Three of the speakers are from our own institute, CSIR, CSIR. So I welcome Dr. Puyam Singh, Dr. Vaibhav Mantri, and Dr. Arvind Kumar. We also have three. Three industry speakers, Mr. Nirjar Bhatt, Mr. Tanmay Seth, and Mr. Bharat Rawal. So I welcome all these speakers. I thank different attendees and participants ranging from the R&D institutes, industries, speakers, academia, students to join us for this session. With this brief, before handing over the session to our session chair, there are a few general instructions. If you have any questions to the speaker, please write in the chat box, and at the end of the technical talks, we will be having a discussion and Q&A session. That time you can raise your virtual hand and then we can discuss the things. So with this brief, now I invite our session chair, Dr. Kanan Srinivasan, Director CSIR, CSMCRI, to present the overview of the session. Sir, over to you.
Thank you, Parul. First of all, good afternoon for those who are in this part of the country and in this part of the world, and good morning for all of the people coming from the other side of the planet, and good evening for the people coming from the opposite side of the planet. I'm sure that there are many people on this very, very unique Science Summit, and that we are organizing it at the behest of United Nations General Assembly. As Dr. Parul said, this particular event, you have to see the Science Summit, which this particular year's theme, Science for the Society and the Well-being of the Mankind, was a major impetus, which is trusted upon. And CSIR very beautifully coined four very, very critical words. It said, first you connect, then you collaborate, then you converge, and then you convert. There's a beautiful workflow with which, the thought process has been emerged. And I'm very, very happy that this particular event is going to demonstrate about all these four C's through the presentations. One advantage that I can vouch for it is, except for Nirjar, whom I have not met personally, other than Nirjar, I know all of them over decades, not the years or months, over decades I know them. So with that kind of a background that I have the privilege of telling this. And in fact, I think one of the major emphasis of this particular session, this is the fourth session in the 6-session series conducted by CSIR. As Dr. Parul said, we are having 2 more sessions in the upcoming days. This fourth session, which the institute, which I belong, the CSIR Central Salt and Marine Chemical Research Institute, is talking about marine resources for sustainable development. I think, this particular the 4 words, marine resources, sustainable development, all these 4 words are going to be extremely critical for the survival of this planet. And lot of opportunities are going to come from the marine resources. Fundamentally, nature has beautifully, when the planet was constituted, it made the marine resources roughly around more than 70% of the planet Earth. Okay, the land resources were literally limited, with a hope that marine resources is going to be helpful for the well-being of the planet. And the speakers are going to talk about on 3 major important domains. And these are very, very representative examples of the marine resources. This is not all encompassing. In fact, I mean, I would say if somebody has to organize only on marine resources, it'll run into what do you call days and weeks. And this is kind of a representative where we are basically talking about three major domains. Namely, I mean, salt, which is coming out of this marine as one of the marine resources coming out of the oceanic origins. And we are going to talk about water, and we are going to talk about seaweeds. And all these three, what do you call, domains are intricately linked with our mankind, be it for food, be it for health, be it for industrial needs, be it for domestic needs, be it for survival, everything that you can see, these three domains is going to be kind of an all-encompassing. And that's the beauty of what do you call the nature offering multiple resources from the marine kingdom. Of course, I mean, the speakers, as Dr. Parul said, Dr. Puyam, Dr. Vaibhav, and Dr. Arvind from the institute, and as well as, I mean, Mr. Nirjar and Mr. Tanmay and Mr. Bharat Rawalji from the industry fraternity are going to be, what do you call, highlighting about what these domains are offering for our sustainable development. And it is important for the people who have joined in the, what do you call, this particular Zoom call, that I have to give a kind of a brief introduction about the institute, or else I'll not be doing a kind of a true justice. This particular institute, the CSIR Central Salt and Marine Chemicals Research Institute, is one of the CSIR laboratories, one of the 37 CSIR laboratories exclusively working on marine resources. There are very, what do you call, a few number of institutes, maybe around 35, 40 institutes and centers on marine resources across the world. People have been, what do you call, spearheading on the exploration of the marine resources. And we are also having a kind of a clear vision with a vision of exploring, harnessing, and transforming marine resources for the good of the people of India and as well as for the world. And that's how, I mean, we were positioning ourselves with a kind of a very clear three missions, namely marine products and processes, marine biology, and marine environment. And if all these three mission verticals, I mean, whatever the topics that we are going to talk, even in this or beyond, is going to be all encompassing. And as I said, these particular topics are extremely relevant for the sustainable development, and especially, I mean, for countries which are having a great difficulty in terms of food, in terms of nutrition, in terms of health, in terms of water security, in terms of what do you call industry expansion, and in terms of entrepreneurship, in terms of skills, in terms of what do you call new business ventures. These domains offers enormous amount of opportunities. And I'm sure that at the end of this, what do you call, session with the speakers from these, and I can tell you, I don't know about Mr. Nirjar very extensively. All the other speakers, and at least I can vouch for my scientists who are going to be present in the call, all of them are having close to 2.5 decades of experience in the domain that they are going to talk about. It's such a kind of a rich experience. And I'm sure aware of Mr. Bharat Rawalji associated on this domain. Again, over 3 decades of experience. Mr. Tanmay, close to now, I mean, he appears in, but I know, I mean, he has been associated now, I mean, going to touch, I mean, the complete, the second decade of his journey on the seaweeds. And with this kind of a rich expertise of more than a century, what do you call, more than a century expertise of these speakers, this session is going to be really, really exhilarating. I look forward to this session, and I'm very, very happy for chairing this session. And I must thank at this point of time my parent organization, Council of Scientific and Industrial Research, for conceiving this thought and giving us a kind of an opportunity and to conduct the session on marine resources. And I look forward to the presentation. As session chair, I just wanted to mention that, I mean, once you have any kind of a queries, you can write it in the chat box. And I'm sure that there should be an hand raise option also. I mean, it is better. You please write the name of the speaker whom you wanted to ask this question also. Like, for example, you can write Dr. Vaibhav Mantri, and this is the question that I wanted to talk to. And that's how, I mean, it becomes easier for the moderator to also clearly, what you call, tell the question and then address to whom, I mean, this question is being asked. So with this, I mean, I look forward to the session. And I request Dr. Parul to take over the session in terms of what you call introducing the speakers, and also at the same time, I mean, maintain the time. Thank you very much, Parul. Please go ahead.
Thank you very much, sir. Thank you for so beautifully putting the tone of this session. So with this, we will start our first presentation. So the speaker for the first presentation is Dr. Puyam S. Singh. Dr. Singh is the Chief Division of CSIR, CSMCRI. He has research expertise in preparation, characterization, and performing testing of various types of membranes to understand structure, property, performance, correlation for water purification and energy applications. Today, he will be sharing his vast experience in advances in water purification and desalination technologies, particularly membrane-based interventions. So, Dr. Puyam, the session is over to you. Thank you.
Thank you, Dr. Parul, and thank you, Director. Thank you all present here today, and good noon, good morning, good evening. I'm very happy and I feel privileged to speak at this Science Summit, United Nations General Assembly 2025. I'll be talking on the work which we have been doing here at CSIR, Surveillance Salt and Marine Chemicals Research Institute, CSMCRI, Bhavnagar, India. The title of my talk is Recent Advances in Water Purification and Desalination Activities. So we talk about water scarcity worldwide. As you see here, I mean, the changes in the last 30 years, the availability of the water is becoming lesser and lesser, and you can see in the last, it is not Indian problem. I also, in the next slide, we have the same problem in 1947. We have like 6,000 cubic meter average annual capita water availability, which is decreased by a factor of 4 times decrement in the last by now. I say hugely alarming situation here in India as well, and we have to make something, make more water available as we look forward. One way of increasing water availability is so-called process desalination, because we have plenty of seawater, ocean is surrounding us, and we can make water drinkable by the desalination process. This is a process where we remove the dissolved salt from saline water. So obviously, by this way, we can increase availability of this potable water. And among all these technologies, desalination, of course, there are thermal and others, and membrane desalination, which is typically known as reverse osmosis membrane, which is among all the worldwide installed desalination capacity by technology. You can see in the graph, 65% is coming from this RO membrane technology, which is more than twice of other technologies, because in other cases, for example, in thermal, we have heating and cooling and pumping. It's kind of changing phase from liquid to gas and again gas to liquid. Is a hugely intensive process. Whereas in the membrane process is only the liquid phase passing through a series of filter, and then we can get the yeah. So I talk about now this membrane, reverse osmosis membrane. In fact, this breakthrough of this process, reverse osmosis, can in 1961-62 by the invention of the Lloyd Sauvirajan cellulose ester membrane. By this is a breakthrough science where we convert seawater into drinking water. So CA membrane are the first generation RO membranes. It is a semi-permeable membrane. It allows the water containing low amount of dissolved salt, and it retains water containing high amount of dissolved salt under external pressure in excess of the osmotic pressure. So in this way, it is the reverse osmosis process of forcing potable water from seawater through the membrane. So this is the reverse to the natural process of osmosis. That's why it is called reverse osmosis. So we here in our institute is a legacy R&D here since 1960s. We have been working this kind of reverse osmosis, membrane desalination R&D here. Though the first generation RO cellulose ester membrane, we also started in the year 1969, and we have developed technologies, and we set up few plants during the 1980 to 90. These are the few pictures I collected, as well as the mobile desalination bus, where we can go places where in the remote areas where there are difficulties of putting on the plants, so we go by mobile desalination bus. And this technology has also gone out of the country. We have given a few plants in Thailand, 1989, and the technology was licensed to various Indian industries. But this is the first generation membrane. It has certain limitations because cellulose ester is a biopolymer, a natural polymer, and is short life because of biofouling, and since cellulose ester is a single membrane made in a single step, so it has certain difficulties in tailoring the structure in a way to increase the performance. So the next breakthrough this is a major breakthrough, is also state of the art thin film composite, so-called TFC membrane. This since 1981, which we call second generation reverse osmosis membrane. Here it is comprised of 3 layers and made in two stages. First stage, middle layer casting, and we can tailor this middle layer by various conditions. This is given in my blue. Some of the parameters I just bulleted points like measure of baking layer, the composition of casting solution, and we can change the thickness, and depending on the conditions, speed, contact time, temperature, humidity of the chamber, coagulating bath, we can control the pore size and the porosity. That way, when you have this middle layer, then it will have, depending on the, we can tailor the top layer, which is a selected layer, and it can be very thin in the scale of nanoscale, 100 to 200. Nowadays, we are even going down to a few nanometers at this top layer. And again, we can precisely control by this final top layer polymerization process, so-called, we say, interfacial polymerization reaction, where we control this absorption of this aqueous monomer and organic monomer, acid chloride, and so forth, and then we get this typical structure. I've shown it chemically. The structure here is a polymerized structure, which is a state-of-the-art TFC membrane. Now, next. So here in our lab, we have kind of semi large scale, pilot scale facility of making this TFC membrane. This I've shown here in the picture is a 100 square meter coating, and so that with this we can roll to spirally, we can make modules of different sizes, and we can put up, we can make plants, small plants to cater for the desalination plants across India and also in abroad. And also this has been transferred to many Indian industries. So these are the, we have deployed through this our manufacturing of our membranes roll, and then making the module in-house, and also we put up a small plant, something about 180 so far decentralized small plants, and considering 10 years of lifetime, I calculate something about we produce 4 billion liters of water, and we scatter about 0.3 million people across India and abroad. The uniqueness of our design is very simple and user friendly, and so that even the villager with little knowledge of education can operate the plant. This is the recent plan we put up few months back this year in the school, primary school in the village called Palitana, which is near to our place here. And this is operation and maintenance is done by the school teacher. Yeah, this one, there's another one. We also look at the water recovery and water purification, reuses of and treating the wastewater, making water purified, and so they can be drinkable. So we launched this UF membrane in India in back 2010, 15 years ago, and now we have many variants now in this domain. We transfer industries again in this. In this domain. Next. So these are the few variants I've just shown here where we can structure different microporosity, and I've just shown you the two slides where we saw the initial feed water contaminated with the bacteria, and then once it passed through this fiber, we get clean water which is clean free from this bacteria. And now we have very high flux and different variants. This I will not elaborate. My industry licensee will talk about many applications based on this hollow fiber. So I will not speak more on this. He will. Yeah, another one is electrically driven membrane technologies. Here we also have where we have the anion exchange and the cation exchange membrane where we use electricity to remove this ionic dissolved salt, cation and anions, and we also can desalinate this desalination technology, electrically driven. And I've just shown on the corner, right hand side up the corner, this is the small plant. We draw the electricity from the solar panel, and we put a plant and to cater for the village. And also high-end purification by combining electrodialysis and ion exchange, we so-called electrodeionization, and we produce highly purified water, so-called ultra-pure water, which is a millipore grade water equivalent, something about resistivity 18 megaohms, and we have different size capacity for laboratory purposes and also semi-industrial scale, 15 liters per hour capacity and also 100 liters per hour capacity. When this is, I have talked about all this static desalination plant, but where there is a difficulties where there is a natural calamities, we have to have this mobile kind of desalination, which is very helpful. At the time of natural calamity, contamination of the drinking water is the immediate outcome, and desalination, mobile desalination is purification. Any source, any kinds of water, either it is coming from the flood water or cyclone or earthquake. So we have this bus housed with different kinds of membrane types. So we can purify, we can desalinate, including the brackish water, sea water, and the wastewater. So any kind of water we can get clarified, purified, and in fact, last week we sent our vehicle to the Jammu and Kashmir flood affected areas and to cater to provide water for the people affected by the flood. And our barn is stationed in the Jammu Kashmir, which is near to Pakistan border. And this also transfer to industry. This kind of service is quite useful for the disaster management. Last slide. When I'm talk about this, when we have this so-called, we have lot of desalination plant is one of the very popular technology worldwide. But then the discarded mineral elements, once the life is over, is becoming a real problem. This membrane waste. So we have now commercial, we have technology which we have commercialized. We transfer this technology where we rejuvenate these discarded mineral elements, and there are industries sending their mineral elements, and we treat here, rejuvenate, and then put on their uses, we send back, and they can be used again. So we extend the lifetime of the membrane. So this is all I have. So thank you very much.
Thank you, Dr. Puyam, for familiarizing us with the various type of membranes like TFC, hollow fiber, ED, EDI, etc., and development and deployment of membrane-based desalination and water purification technologies. Thank you very much. With this, now we move to the next talk of the session, where our industry collaborator will elaborate upon the applications of hollow fiber membranes for water purification. So let me share the screen. Mr. Nirja, can you see the screen? Let me share it.
Yes, I can see the screen.
Yeah, it is in full screen mode.
Come again? Yes.
All right. So the next speaker is Mr. Nirjal Bhatt. He is the director of Memtrix Technologies LLP. He is masters in chemical engineering, and he has 20 plus years of experience in water and wastewater treatment technologies. Today, he will be giving us an industry perspective on sustainable water purification through hollow fiber membranes. So over to you, Mr. Nirjan. Please let me know when to move the slide next.
Thank you, madam, for giving me this opportunity to share my experience in sustainable water purification using hollow fiber membranes. Can you go to the next slide, madam? Okay. Now, basically, water purification, what technologies are we using for water purification? So we all know that domestically we use RO, media filter, chlorination. Industrially, the technologies which are very popular are ME, MBBR, SBR, spiral, reverse osmosis membranes, spiral nanofiltration membranes. Then at community level, wherever we get water from our taps, government uses chemical dosing, chlorine dosing, sand, carbon. So we know all these technologies, and we have been using these and depending on these technologies since now almost maybe 100 or more than 150 years. But then, as we are all aware that all these technologies have come to their limits, which will be in the next slide. Can you go to next slide, madam? Yes. Now, all these water purification technologies have reached their limits. Now, these are just few limitations that I have listed. I am sure that my industrial partners and the learned can list out more, but then few of the limitations that I can say very easily are, say for example, reverse osmosis, which is used everywhere for water purification at domestic level, at industrial level. There is a lot of water wastage. The membranes are prone to fouling. There is immense need for pre-filtration. It means that pre-filtration is such a big headache when it comes to reverse osmosis. The current technology, what I'm talking about is the current technology membranes, not the technology per se. And the unsustainable disposal of membranes. For example, right now there is no sustainable disposal of membranes done, and neither anybody is focusing. Just now, Dr. Puyam Singh mentioned that they are trying to reuse their membranes in a different way, but still everybody is looking for some sort of unsustainable disposal options. Everybody would have seen heaps and heaps of discarded RO membranes which have no other use. When we come to industrial water purification technologies like multi-effect evaporators or biological technologies, everybody knows that multi-effect evaporators are a very energy intensive. The disposal of waste for example, from ME, the solid waste which comes out is a big challenge. And all these technologies used at industrial scale are high pressure, and very costly. For example, there are certain ME multi-effect evaporators which are made of titanium because of the salts which are being handled. The energy which is used, the thermal energy which is used in all these technologies also is very energy intensive. And yes, when it comes to reverse osmosis being used for industries for removal of BOD and COD and for water reclamation, it is altogether a new challenge for the industry. Now, when we come to chemical and chlorine technology, then we all know that chemical technology water. For example, the new microplastics which are emerging in our underground water, the trace chemicals which are there in our underground water sources, or even in rivers and everywhere. The current coagulation technologies are unable to address them. The chlorine technology which is used for disinfection of water, it is disinfecting, but then at the same time it is creating another secondary effluent or secondary chemicals which are more harmful than the bacteria itself to the person who is using them. So it is like a cascade of inefficiencies which is existing there, which is existing in our current water purification technologies. Next slide, please, madam. Now, coming to hollow fiber. Now, what is hollow fiber? Before coming to the advantages of hollow fiber, I will just give a brief about why hollow fiber and what is an hollow fiber. See, basically, we can think anybody who is not dealing with hollow fiber can think of hollow fiber as a very fine tube which has pores on its surface and it is hollow at the bottom and which is made up of polymer. So, what we are talking about here is all polymer based products. Now, all these hollow fibers will be made from polymers like PES, PAN, PVDF, and even PTFE recently has been introduced. Now, advantage of this hollow fiber is that they can give filtration in the range from micro to nano. So we can move from say maybe a 5 micron filter to 5 nanometer size of a pore size filter using the same material or maybe some combinations of material here and there. So basically hollow fibers gives us a very broad range of application when it comes to water purification, and with advancing technologies not only hollow fibers can play a role in terms of a pressure driven filtration system, but they can also play a critical role in terms of thermal driven pressure system. So they can move from a pressure to a thermal or a combined technological combination to give us range of water purification as per our requirement. Next slide, please. Now, I have the title of the slide is hollow fiber miracle product. Now, why we consider as an industry, I consider as a miracle product. The first thing is it is a gateway to like why hollow fiber is a gateway to sustainable filtration. From my point of view, from the industry's point of view, that hollow fiber products are easy to make. Anybody who has worked with hollow fiber knows that they can be easily made using NIPS process. What we will be dealing with is NIPS. Very broad range of polymers are available, PVDF, PES, PAN, PEI. So we can combine these polymers and get any kind of hollow fiber properties that we desire. The porosity is easy to control, easy to modulate its surface properties. Like there are n number of or maybe terabytes of literature available today on internet, which provides us enough material to modulate the surface properties of the hollow fibers, making them hydrophilic or hydrophobic or oleophobic, any way we desire. Now, another important thing is these polymers are recyclable to a lot of extent. So, if enough research is done on that line, then there is no need to throw these hollow fibers in landfills. We can take used membranes, we can recycle them and convert them into brand new membranes. These hollow fibers have a high packing density compared to spiral membranes. So wherever we all know that space or the cost of land is a key important thing whenever any project comes, whether it is in India or whether it is anywhere else. So these hollow fibers have a very immensely high packing density. So when we move from a spiral wound membrane technology to hollow fiber membrane technology, then maybe the packing density we will get is almost 3x to 4x, or even sometimes it is even higher. And modular hollow fiber technology is modular and mobile. We can, because of this low packing density, we can make mobile plants which can provide clean drinking water at maybe a disaster prone area, or a maybe flood affected area, or maybe a completely decentralized water treatment process, which I will cover in the next slide. And they are energy efficient and low pressure. Whomsoever has worked with hollow fiber, just previous slide, madam, again. Can you, thank you. They are energy efficient and low pressure. Hollow fibers, anybody who has worked with hollow fiber knows that they can operate at a low pressure compared to a low. Okay, and lastly, recycling of these membranes is possible. Very less attention right now is being given to recycling of this membrane, but I think that recycling of water filtration membranes, specifically hollow fiber membranes, will be one of the key areas in which, like for example, we have recently, I have recently come across certain articles which are limiting use of certain polymers in European countries for water filtration. Recycling of these membranes will play a key role, because whenever a producer will be able to prove that their membranes are recycled and not made from virgin polymers, then they will have a better market reach compared to polymers which will be by design will need a virgin material. Next slide, madam. Okay, now one example. There are n number of possible examples, but this is a simplified drinking water purification schematic which shows that how hollow fiber membranes can play an important role. For example, this slide shows that we can make a very simplified drinking water plant. The source can be either river water or maybe groundwater, which can be coagulated, which is shown in this slide as a chemical dosing, clarified and directly purified using nanofiltration or nanopore hollow fibers, having porosity in the range of maybe 10 around 10 nanometer to 5 nanometer, giving us a pure drinking water without any kind of chemical addition, without any kind of major chemical addition. Now this schematic, what are the benefits of this schematic? Now it makes drinking water simple, scalable and very versatile. Okay, so this entire schematic can be adopted either at a small community level, or it can be extrapolated to a large state level, or it can be extrapolated into small containers. It can be made very mobile, and also the benefit of using hollow fiber at this place is that even if the coagulation or flocculation has some sort of an issue due to weather fluctuations or anything else, the hollow fibers will be able to take all this load. Okay, so here hollow fibers can play an important role cutting down everything, and if the source water is not very aggressive in terms of pollutants, then simply passing it through nanofiltration membranes can give us a very good quality of drinking water. So hollow fibers in drinking water, simple, scalable and versatile product. Hollow fibers cannot, so this will not only address the pathogens, but it will also address trace chemicals and emerging pollutants like microplastics, and even in some case we can reduce or we can partially soften the source water. So this combines, it is like a completely packaged single product, giving pathogen removal, giving contaminant removal, and also giving trace microplastic removal, which is one of the major emerging contaminants. Right now all the European studies are moving into how to remove microplastics from water. So here hollow fibers can play a very important role. The process is compact, mobile and cost effective. Next slide, please. What are the opportunities now? Industrial, because I am from the industry, I am giving an industrial perspective. What are the industrial opportunities? Where the real projects, where the real money lies? Revamping of old water treatment plants with HF technology. So anybody who will go to the new urban areas, or the new cities which are developing, new colonies which are there, everybody knows that the current water infrastructure will not be able to provide them clean, safe drinking water. without either making the groundwater unsustainable, year on year dropping of the groundwater levels, unless and until new technologies are introduced. So here, revamping of old water treatment plants with HF technology is one of the big opportunity. Rapid development of decentralized plants, which meets more stringent of norms. So see, today we need decentralized water treatment plants, whether we talk about industrial wastewater or community driven water treatment plants. So hollow fiber gives us that kind of an easy and fast deployment because the infrastructure requirement is very less. In the cost of laying down 1 kilometer of underground water piping, we can make the same plant as a point of use point of use plant, which will give us clean, safe drinking water. So it's, say to a remote area, rural areas, everywhere. Recycling of chemicals, water and chemicals from industrial wastewater. Here the technology is like membrane distillation, which where hollow fiber plays a very critical role. We can reuse water and chemicals. For example, already there are case studies where hollow fiber as a membrane distillation product is used for desalination of seawater, wherein by desalinating the seawater and converting the concentrate into reusable salts at pressure and temperature, at a normal pressure and normal temperature, or maybe temperature in the range of 70 to 50 to 70 degrees. Already pilot plants are coming up in this line, and everything is done using simple hollow fibers, no big technology, just good chemistry of the hollow fibers coupled with thermal and pressure driven processes, improving reusability of industrial wastewater. So everybody today knows that water availability, as Dr. Puyam stressed, that drinking water availability or potable water availability will be one of the major cause of concern for industrial growth or growth of India and growth of world as a society. Hollow fibers can make this industrial reuse of industrial wastewater very easy, very energy intensive, very less energy intensive, and very sustainable, because we can reuse the chemicals, we can reuse the water, and at the same time, when the hollow fiber membranes are out of their life, we can reuse the membranes also. And lastly but not the least, hollow fibers can be the next generation of diesel tech. See, since now almost 50 years, all the pressure is on the RO membranes for desalination. But if enough research is done, and CSM CRI is doing a lot of research in this area, then desalination, when it moves to hollow fiber, then it will change the nature of desalination totally, making the plants more compact, more energy intensive, less energy intensive, and giving an end-to-end desalination process. Next slide, please.
Mr. God.
Mr. Nirjar, please wrap in 1 minute. You have
Yes,
exceeded already.
only 2 slides left. So here we come to Memtrix Technologies. We have been working with hollow fiber in association with CSM CRI, and this is the graph we started only 2 years ago. But with association and with good guidance, we have been developing and manufacturing and marketing hollow fibers. Next slide, please. Our strength lies in R&D. So this slide shows our association, almost now 2 years of association with CSM CRI. We have been the culmination of all this is mentioned by Dr. Kanan of CSIR, collaborate and from collaboration to ultimately deployment of the final product to the industries. Next slide, please. Next slide. And this is our development till date. Thank you. Thank you for listening to my industrial perspective on hollow fibers. Thank you very much.
Thank you, Mr. Nirjar Bhatt, for presenting various water purification technologies and some of the limitations and how hollow fiber membrane-based filtration technology is the future for the water treatment. Thank you very much. Now we have our next speaker, Dr. Vaibhav Mantri, who is the senior principal scientist and divisional head of applied phycology and biotechnology division of CSIR, CSM CRI. He is having research experience in cultivation of important seaweed, strain improvement and artificial seedling production development of scalable seaweed farming methods, study of environmental factors affecting growth, and evaluation of environmental impacts in tropical waters. Today, Dr. Mantri will be sharing his expertise around marine algal or seaweed cultivation and downstream processing. So over to you, sir.
Yeah, thank you very much, Parul. And as she rightly said that I'm going to speak about marine algal cultivation, which is my actual as a scientist as my domain, and also as a downstream processing, which we have been doing at CSIR, CSMCRI. And as she used, if you have clearly listened to her, she used the term seaweed. Marine algae, basically marine macroalgae, they are also named they are also termed as seaweeds sometimes, but seaweed is negative term, so I prefer to use word marine algae. I'm sure that many of the people who are listening to this talk may not be aware of what is marine algae. So I just take a moment and I would like to explain that they are basically a macroscopic plants which are occurring in sea, and they are multicellular. But very interestingly, although they are termed as marine algae as a group, phylogenetically or evolutionary perspective, they are unrelated. Uh, and for a convenience of people, they have been identified under three groups based on their pigment content, to a layman based on their color, that is red, rhodophyta, brown, phyophyta, and green ones are known as chlorophyta. They are very, very important plants and they give lot of ecological services. That means they are supporting the marine ecosystem in terms of carbon fixation, providing habitat for breeding and growth of marine organisms. But since we are talking about industry, they are very much important as an industrial raw material. And if you see a global trend, which I will be showing you in the next slide, but just to understand that around 77% of this feedstock goes as an edible purpose, for human consumption, and it in terms of value it is around 88%. Rest of it goes for the polysaccharide extraction. If you see a global perspective, I have given the most recent data of FAO 2022, and this is the map. Basically, there is 35 million metric ton is the annual production, which is close to 16.5 billion US dollar market. And very interestingly, 20 years ago, if you see, they were gathered, but now after 20 years, today 97% of this feedstock is cultivated. Then on the right hand side top, you can see that although there are 220 species commercially exploited, and I'm sorry, there are 10,000 seaweed species globally available, of which 220 are commercially exploited. But when you see this 97.1% biomass, it comes only from 6 to 7 species, and those I have named there. Saccharina is one of the brown seaweed, which is largely produced, followed by green seaweeds, Gracilaria and Euchemoides. And also there are only 5 to 6 countries, mainly Southeast Asian countries. They are the dominating nations which are producing it. Indian scenario is definitely very encouraging nowadays. You can see at the right hand side bottom graph, we in India have produced 8,000 tons of dry feedstock so far, which is around 23 million of the market value. It has come only from a single species, that is Capophycus, about which I will be shortly telling you the information. If you see why seaweed, why marine algae or seaweed, so when you see an Indian perspective, and there are several biological resources which have been exploited, and if you see, India has around 11,000 kilometer coastline of about 2.5 million square kilometer of exclusive economic zone. And if you see last year's data, Indian fisheries sector has achieved all-time high seafood export. But when you see to the artisanal fishermen, the things are not very good, and their fish output also has dropped. Infrastructure, there is a tremendous gap, especially for a small scale fisher people, and their marine algae can basically support them. Although, I showed you the last 2 decades progress, but collection of seaweed is happening for the last 5 to 6 decades, and this is largely an unorganized sector. It has a lot of problems like pronounced seasonality. Then all these fisherwomen who are involved in collection, they do not have direct linkages with the industry, so they have to go through middlemen, agents, and they also exploit them. A low remuneration they get for such a hardship. You can see some of the pictures which I have given where women are diving, and you will be surprised to know there are only two nations where there are women divers. One is Japan, where they go and dive for certain kind of seafood. And in India, we have women in Tamil Nadu and some parts of other coast where they go and dive and collect seaweeds or marine algae. So seaweed marine algal cultivation is especially for empowering those women who are doing hardship, and also coastal youth. This activity provides a stable livelihood to the coastal communities. I'm just giving a glimpse of our innovations. These are US patents by CSIR. Why I'm emphasizing this innovations is, if you see a global practice, be it other nation, other Southeast Asian countries or any other country, many of them, they basically export their feedstock to European countries or American countries for basically processing it. So their feedstock value depends on the global market trend. But if you see in India, although we were doing export in the beginning, now our domestic needs are very high, and we are processing almost entire feedstock now in India, and that's how we are insulated from the global fluctuations in the price, and that's how our seaweed farmers are getting better remuneration. CSIR has developed several technologies, especially for processing with a backward integration of cultivation. This picture shows you what kind of processes and technologies we have. Just to name a few, there are technologies available for Gillidiella acidosa, Gracilaria dura, Gracilaria divilis. These are the seaweeds for agar, and Entomorpha flexuosa, Entomorpha Kapaphycus, etc. And some of them have been already transferred to several Indian industries. More than 20 industries we have transferred these technologies in last 5 to 10 years. And I'm very happy to say that now this has been a big activity, especially in Tamil Nadu coast, as well as some parts of Gujarat, Maharashtra, and Andhra Pradesh. This slide shows you how this cultivation has evolved. When my colleague, Mr. Tanmay, is going to talk, he is going to tell more, but just to say that few words about it. Initially, after our technology was transferred, it was a higher level model, like any plantation kind of activity. They were hiring as and when people required for doing cultivation. After that, when that was successful, and when people understood that this can give some kind of remuneration, contractual farming model has come, where company has made a contract for a buyback agreement with the farmers. After that, Kudumbakam or a family model has come, where entire family is engaged in farming. And you can see that because of this kind of thing, there are work responsibilities divided. Also, there is one kind of ownership. When family is there, they feel that it's my farm, it's my activity. And then extended family model has evolved into self-help group model, which is basically a unique for our country. It is nowhere else is practiced, and where group of 10 to 15 people, they join together and they cultivate. Besides this cultivation, I'm very happy to say that in last 5 to 7 years, around 5,000 beneficiaries we have trained. Beneficiaries means I'm talking about fishermen and fisherwomen. This has largely come from our flagship program of CSIR, that is a skill initiative. We are also happy to inform that CSM CRI has given lot of inputs for developing these kind of training and skilling programs throughout the nation. Largely Agriculture Skill Council of India, they have a program, and we have given a lot of science-based directives to them. Niti Aayog also has brought a program. We have given inputs. Also, we have been doing a lot of trainings, largely for sponsoring agencies like GSBT, MDST, and several state government fisheries department are approaching us to train their newly recruited field officers. So we are doing that also. Now, if you see like any other farming, you need a seed. You need a quality seed to propagate this, without which there cannot be, success. And I'm very happy to say that in India, we are the first one to have a hatchery kind of setup. A big seaweed seed production facility has been established at our marine algal cultivation center at Mandapam, and this is the first such facility where we have been producing elite seedling. Also, we develop a project with one of our industry partner, Pidilite, and they also have established a very good infrastructure very near to Bhavnagar. And you can see that all these seeds are produced. Largely, we are working on 3, 4 different seaweeds, but perfected the technologies for Tacophycus alvarezi and Gracilaria dura, which has lot of industrial value, and around 10,000 to 25,000 plantlets per batch. Such a scale we have already reached, and these two technologies have been included as top 100 Indian innovations of 2023. And this micro propagation based technologies assures a good crop productivity. Coming to land-based cultivation, this is very, very important when you basically talk about edible stuff, because in the open sea you have no much control on what is there in the surrounding. So we have been working on two important algae. One is alga and one is monostroma, which is now known as gyrelia, and we have scaled it up very nicely. You can see the biggest challenge in this algae especially, because unlike red seaweed, it requires spores to propagate. And I'm very happy to say that our colleagues at Bhavnagar and Mandapam both, they are very successful in inducing spores, especially in alga. And also we are beginning with monostroma, where also we have got some good leads on spore induction. And we have shown it from laboratory to indoor tank, then to outdoor tank, and to harvest this. So we have very successful technology. Very recently, this has been patented. So I think I have now only one or two slides. When we talk about application, there is a very important discovery our scientists have made, that largely all these seaweeds, polysaccharide yielding seaweeds, were processed only to get polysaccharide throughout the world. But for the first time, our colleagues have shown that it can be processed into two unique products. One is sap, or it is also called as biostimulant, and this biostimulant has two applications. One is as a plant biostimulant and animal biostimulant. Our colleagues have collaborated with several centers of ICR institutes, and to be very precise, 43 different centers throughout the India. Multi-location trials on several crops were conducted, and I'm very happy to say that the crop productivity and yield has increased around 11 to 40%, depending on crop. Some of the examples like rice, maize, green gram I have given, but this has really given a big impetus to cultivation. Also, very recently we have been working with AquaAgri. I'm sure Mr. Tanmay also will say about it. we have studied this biostimulant for animal feed, and it also improves gut, it also improves the body weight, and also in poultry, also it gives very good results. The next one is about polysaccharide. As I said, polysaccharide is very important component. Entire India, all the industries, there are around 46 industries. They all are involved in polysaccharide processing of seaweeds for polysaccharide. And we have been now more focused attention has been given for zero liquid discharge processing technologies, because you all know that water footprint is very high for polysaccharide production, and I'm very happy that some of the technologies which we have recently developed are totally zero liquid discharge, and one of the technology for alginate production which has already been transferred, which is zero discharge technology. In case of agar, we were successful in producing very high quality agar as per the industry specification. One of the largest industries, High Media, we have been working with them. Also, I just take 1 minute to say that as we talk about industries, the benefits are not directly transferred to the end producer, farmers or a fisherman in this case. So what we have developed is the idea of Dr. Kannan, it's his brainchild. We have developed an Empower model where we have worked with Tamil Nadu government under their World Bank project, and we have established 0.5 TPD tons per day processing plant at Mandapam, and we have also given a training to fisher people to process their own feedstock. And this was very successful model, and I'm sure several other industries have several other state governments have successful model will give lot of remuneration and benefits to fishermen. Now, I think this is my last slide. As I said, it is very good, and I'm very thankful that our parent organization, CSIR, has given a lot of funds for a seaweed mission program. Now we are in the third phase, and we have been doing multi-locational trials as pre-feasibility studies for entire Indian coast, and so far 62 different sites were identified where commercial cultivation can be taken can be taken up. And as I said in my previous slide, that we have been producing elite germplasm, and I'm happy that Ministry of Fisheries has given us a project in which we have produced 300 tons of good seed material, and that has been distributed to the fishermen of Tamil Nadu. There are few concerns about biosecurity on which we have been working very hard, and I'm very happy into giving lot of science-based policy guidance to government, and a few gadgets have come through Ministry of Fisheries. I'm also happy that apex body, that is Niti Aayog, has also brought up a strategy for development of seaweed value chain. It's a big document, which is a first policy document in the country, and there we are. We were very happy to give such kind of policy guidance to the government. With all this, I'm very happy to invite people who are listening to us from other parts of the world, that these are some of the technologies available with us. We have also a lot of collaboration going on, and these are some of the organizations like University of Malaysia, then Scottish Association for Marine Sciences, University of Philippines, etc., with whom we have been working, and were able to brought out several publications. And with this, I invite people to CSMCRI, CSIR, and lastly, I'm thankful to all the participants for their kind attentions. I also thank DGCSIR, ISTAD Head and Director CSMCRI for giving me opportunity. Thank you very much.
Thank you very much, sir. Thank you for sharing about marine algae scenario, their vast applications, cultivation, innovation by CSIR, technology transfer, and skill development to empower coastal community. Now we will be having our next speaker, Mr. Tanmay Seth. Mr. Tanmay Seth is the director of Aqua Agri Processing Private Limited. He has a master's from the University of Nottingham, sustainable, and he is expert in sustainable agriculture and aquaculture. Mr. Seth will present the industry outlook around seaweed innovation in action. Over to you, Mr. Seth.
Thank you very much, Dr. Parul, and good morning, afternoon, and evening to all the attendees. Thank you to CSMCRI Director, CSIR, for allowing us this opportunity to present today. I think Dr. Vaibhav has set the tone on the subject we are going to talk about, marine resources for sustainable development, and specifically seaweeds innovation, in my case. Could we go to the next slide, please? A very quick introduction. I'm Tanmay. I've been working in this since 2008. And right now, we see seaweed as an opportunity which is very much larger than what has been achieved today. And there is clear focus from the highest leadership, the Prime Minister of India, earlier, late Dr. Abdul Kalam. He said something very, very interesting, that seaweed is something that neither requires land, nor water, nor fertilizer. Instead, it yields fertilizer, captures carbon dioxide, and is available as an activity to people who are landless and live along the coasts of India. So India has a very large coastline, but to also correct that statement to say not the entire coastline can be exploited for cultivation. There are pockets which are suitable, and CSMCRI has done some incredible work in identifying those spots which can then be taken up for cultivation across India. We believe at least 100,000 people can get employment from this activity. Today, we are somewhere around 1,500 families are engaged in this between collection and cultivation. So the scope is enormous. I think the per capita income in India is expectation is lower than Philippines and Indonesia, who lead currently seaweed cultivation, especially of the species that we are also trying to grow in India. So there is no reason why we should not come on the seaweed map and build India in this domain. The biostimulants, which again Dr. Mantri touched upon, which can be extracted from tropical macroalgae, have been proven to reduce chemical fertilizer requirement up to 25% by various studies conducted by CSMCRI and further studied at agriculture universities and ICR institutes after their study by Aqua Agri and then IFCO. Seaweed biostimulants can also bridge the productivity gap in organic production where nutrient use efficiency. Very recently, a major hurdle was crossed by Central Fisheries Ministry releasing a gazette which will now allow import of fresh germplasm into India, which can open the door for cultivating beyond the single species on which we have been dependent, the other 3 or 4 tropical algae, which are commercially cultivated across the world, as shown by Dr. Mantri. Next slide, please. Just Aqua Agri's vision and mission, I think we are very clear that for cultivation and growing seaweed, it should be done to empower the coastal communities, ensuring viable and scalable business models which benefit society and have a positive impact on the environment. Seaweed does exactly that. And our belief is that processing the algae for various value added applications, such as biostimulants, hydrocolloids, and other newer areas where it can be used would be the business opportunity. But first, we need to scale up on the cultivation side, and that remains the heart of the company in regards of mission and vision. Next slide, please. This is the journey that has happened so far. This program was initiated back in 1998 when Master Foods Mars suggested to PepsiCo India at the time to look at seaweed farming to exploit their contract farming experience. The only laboratory which had done work was Central Salt and Marine Chemical Research Institute, who had already worked on seaweed cultivation, and a, a long journey between 98 and 2005 on research on how do you take this up from a few grams to a few kgs to a few tons was taken up to actually reach a scale to start commercial cultivation in India. AquaAgri was incorporated and the business was transferred. By 2010, we had at least achieved enough scale in India to set up a value-added facility for manufacturing biostimulants and hydrocolloid carrageenan at Tamil Nadu, where the cultivation was happening. I think everything is explained later also in the slides, but it's critical to highlight that the partnership completes between science, manufacturing, and marketing. So until 2017, when AquaAgri, thanks to all the data generated by CSMCRI and the work done by CSMCRI, could convince the world's largest cooperative, IFCO, to start marketing this product. That's when the whole circle completed and we could really successfully commercialize. 2017, the joint venture with IFCO took place with AquaAgri. When scale was achieved on the market side and the business had sustainability, this technology also could be taken offshore from India, and we started looking at Sri Lanka, which has exactly the same conditions as Tamil Nadu, to further the effort of cultivation and taking the technology which started in India with CSMCRI to other parts of the world. Because of climate change problems and other factors, creating seed in the lab has become a necessity, not only for us, but globally, for which CSMCRI again started the work of having the first micropropagation facility in Mandapam Research Station, which has been the base on which we have expanded further to now have an industrial scale facility. Next slide, please. This is a few shots of early days of cultivation. I got these. Was the very beginning. A 20-gram piece of Kappa ficus was brought from Japan by Dr. O.P. Mehra from CSMCRI in '84. And that's where the journey began. Pilot scale. This work has been undertaken by both ourselves and CSMCRI to grow seaweed in India and along with combating. Next slide, please. This is who we are and where we stand. We've pioneered seaweed cultivation with CSMCRI. Today, thanks to IFCO, we would be the #1 biostimulant producer with the largest market share. Biostimulants are crop and climate agnostic products. I think there's a huge opportunity of exports as well to take the product all across the globe, because we are far more competitive than mined algae on which this industry was earlier anchored. But tropical algae, thanks to the research done, has proven to work as effectively, if not better, across agriculture, across geographies, across soil types. This was very well proven with the study mentioned by Dr. Weber on across 43 agriculture universities for 3 years on 9 crops anchored by CSMCRI. Cultivation meets 13 out of the 17 sustainability development goals. and it has a huge impact on mitigating climate change as seaweeds sequester carbon dioxide. Today, we have a reach of reaching 55 million farmers through IFCO. We haven't reached there, but we've touched the surface right now, but the opportunity is huge. There's 1,200 plus families along coastal India now undertaking collection and cultivation of seaweeds. We ourselves handle 7,000 tons of dry seaweed per annum. We have 20 plus years of relationship with the coastal communities. There's a trust, there's a belief that we are going to stand by them and work with them to grow India in this field. I think the model has been quite simple. There is a trust because everything they grow is bought irrespective of the market need at a fixed price, assuring the livelihood and assuring sustainable incomes. We continuously do R&D to further the quality of processing and cultivation. Next slide, please.
Mr. Bhatt, you have 2 more minutes, please.
Sure. So I'll have to rush a little bit now. So this is just a quick graphical shot of what we do. We have micropropagation, cultivation, post-harvest analysis on quality, biostimulant production, and hydrocolloid production. We check quality. We also check the product because earlier biostimulants were doubted as they work sometimes and they don't work sometimes, but very scientifically, with a lot of work done, and credit to Dr. Arup Ghosh from CSIR for leading this. He's brought in adequate data to back the claims on why these products work in and across geographies. Next slide, please. The impact we've had so far, I'll skip anything that is repetitive. This activity majorly lends itself to women. 75% of the workforce in cultivation is women. Even at our factory, 50% of the workforce is women. This is estimated that 7,000 tons of carbon has been reduced with the quantum of cultivation done by our company. Crop yields can be increased 15 to 35%. In animal feed, we have proven that tropical algae can reduce methane emissions to the tune of 35%. If the farmers were to reduce 25% chemical fertilizer, till date 6,500 crores of subsidy saving impact can be seen. Next slide, please. The socio-economic dimensions. There's a study done which was funded by FAO and conducted by CMFRI, which is available in the public domain, which took AquaAgri as the case study and clearly brought out that women empowerment is clearly demonstrated by cultivation. It promotes entrepreneurship. And most interestingly and importantly, income in the hands of women ensures spends on children's health, education, asset creation, and savings. It diversifies income, the activity, and prevents falling income, which has been seen with fishing activity. And the self-help group model has worked very well in Tamil Nadu. Next slide, please. The environmental impact, seaweed is a natural carbon sink. We believe once we scale up, there's an opportunity for ocean acidification, and can create a new habitat to increase aquatic species. And the climate change currently is impacting seaweed cultivation productivity globally, for which, next slide, please. For which micropropagation at an industrial scale has been commenced, and we hope that we are able to create adequate seed which can promise predictable income and output to farmers within this financial year. Next slide, please. We are happy to call ourselves as the market leader in seaweed-based biostimulants and have set up the largest carrageenan production facility. We have now separated the plants and have taken food grade clearances of global standards. Next slide, please. This is the innovation pipeline on the areas of work and focus beyond what we do today. I think biodegradable packaging, substituting plastics is a very high area of interest globally on which we are trying to see how seaweed can play a part. Also looking at new applications such as coating seeds, slow release fertilizer, um, using seaweed as part of food solutions, biodegradable cutlery, sea salt, on which Dr. Weber has partnered and done some very good work. And we have a publication as well. Also in nutraceutical area, there is a huge scope of using seaweeds towards anti-obesity, personal care products, on which we continue to work together with the Indian science system and especially CSMCRI. Next slide, please. I think the most important formula for success has been the integration between a research institution, an industry partner, and finally coupled with a strategic marketing partner. That makes a formula for success. Otherwise, the puzzle is incomplete. So this slide just shows that if all three come together, we can make a huge impact. Next slide, please. Thank you very much. Sorry, I went a few minutes over. Thank you to CSMCRI, and I hope I could give the short 10 minutes.
Thank you, Mr. Seth, for providing the seaweed opportunity and AquaAgri's collaboration with CSIR, CSMCRI to take this marine resource, that is seaweed, to a commercial scale and further. And it's truly fascinating to learn that the seaweed is associated with the 13 SDGs out of 17, which is truly remarkable. Now we are moving to our next speaker, that is Dr. Arvind Kumar. Dr. Arvind Kumar is Chief Scientist and Divisional Head of CSIR, of Salt and Marine Chemicals Division of CSIR, CSMCRI. His research expertise is in physical chemistry of brine systems, recovery of high purity salt and marine chemicals from brine, saline effluent management, ionic liquids and salts, and their use in material applications. So Dr. Arvind Kumar will discuss a very key marine chemical, that is salt, as well as other specialty chemicals, recovery technologies of CSIR, CSMCRI. Over to you, sir.
Thank you, Dr. Parul, and thank you, Chairman, and all the audience for joining this session on marine resources for sustainable developments. I will be talking about the solar salt technologies at CSIR, CSMCRI. So this activity being the parental activity of this institute, because salt has a connect to the Indian audience because of obvious reasons of Indian independence. So an important activity is being carried out in Central Salt and Marine Chemicals Research Institute. So the content will be like understanding seawater composition and mineral abundance for solar salt manufacturing. I will go through a little bit about the global and Indian scenario regarding salt and marine chemicals, and it will be mainly covered by our the partner, industry partner, Mr. Bharat Rawal, in later presentation. And when we talk about the sustainability of this solar salt production, we talk about its quality and yield through scientific interventions, and then value addition in solar salt works, different kind of specialty salts, and generation or utilization of the bitter, the liquid which is remained after the solar salt productions. So these things, these activities bring more sustainability to solar salt manufacturing process. Before we talk about the solar salt production, we need to understand the chemical composition of seawater. Salt constitute about 80% of the total, salt, I mean sodium chloride, it's a common salt. So 80% of the total salts in seawater, followed by other salts. If you can see this graph, a bit technical one, this dotted line, all the elements beyond right side of this dotted line are the potentially attractive for extraction, provided suitable methods of extraction are available. And the elements which are left side of this dotted line, they are not cost effective so far for the extraction. So we are working on the most abundant material, that is sodium chloride, which I call a mother chemical for chemical industries. We are doing different cost-effective methods, sustainable technologies for harnessing all such kind of bulk and trace metal salts at CSIR, CSIR. And if you see the global and Indian scenario for the salt production, India stands third after China being the highest salt producer, more than 65 million metric ton, followed by US and then by India. Actually, if you see the figures of this years, we are fast catching US and becoming second largest salt producer of common salt. The market is attributed grow annually at the rate of greater than 3% worldwide. And if you look at the application of common salt, they are tremendous. De-icing, power industry, water treatment, and chemical processing. Chemical processing is one of the the biggest, for example, chloral cleared soda ash. Sodium chloride is used as the raw material, and demand is increasing day by day. The market is very good. 25 billion USD is the total market of common salt. And if we say about the India, there are, I have circled in Indian map. The main states are Gujarat. Gujarat produces more than 75 of total salt production in India, followed by Rajasthan, Tamil Nadu, and all small dots on Indian maps at the coastal. Because India is a huge coastal land. There are small pockets which are manufacturing salt, but the total, the most of the majority is covered by the Gujarat only. And production is through sea brine. 82% of the salt in India is produced from seawater only, followed by some underground waters. We have certain lakes also. If you can see these pictures, the Sambar Lake is an inland lake in Rajasthan, which is a huge lake surrounded by 3 districts and comprising of high density saline water, and good quality salt is obtained from this lake. And we have certain ropes also. For example, in Mandi, Himachal, we have lakes. We are harnessing salt out of these lakes. And if you look the consumption pattern of Indian salt, human consumption is nearly 60 million metric ton, followed by exports, and then industries. Industries in India are the major consumer of common salt, and exports also. India, right from the independence to till date, we are now exporting salt to the 55 countries of the world. So India is playing a big role in solar salt manufacturing and providing salt for edible purpose as well as industrial uses to the whole world. And this is the very conventional common practice for salt manufacturing. Seawater is taken into reservoirs. It is then concentrated into condensers. And then there is a marginal or small area where common salt is precipitated and harvested and taken to refining and then used for various applications. If we look at this chart, 90% of the water has been evaporated till common salt is obtained, and this 10% water is a huge resource for marine chemicals. For every 50 meter cube of the seawater, we can get 40 to 50 kilogram of very good quality gypsum, and then bittern. Equal amount of bittern is being generated as the amount of salt. And this bittern has a great potential to integrate with salt manufacturing practices. We receive potassium chemicals, magnesium, bromine, and other critical minerals can also be associated to make salt industry more sustainable. So utilization of bittern along with the recovery of common salt is likely to make solar salt manufacturing practices more sustainable. So these are the steps involved in salt production. Earlier I saw a sketch, and then you can see that seawater is pumped into reservoirs, condensers, then it is crystallized and then harvested, transported, and finally refined and taken to the industries. So this is the whole process of taking seawater to manufacturing salt. And if you look at after crystallizers, if this making or manufacturing is integrated through recovery of marine salts and other chemicals, then we can make salt manufacturing even more sustainable. And if we need to generate pure brine in solar salt works and can directly supply a saturated brine to the industries. So this will be a great idea to sustain or reduce the hardships in solar salt manufacturing. Institute has patented these ideas and working with CSIR funds and industries partnership on a large scale to see the light of the day for this technology where pure saturated brine can be supplied to the chloral clay industries. And we have also brought sustainability to solar salt manufacturing operations through various quality improvements. A lot of technologies have been developed in the institute for improving the quality. For example, through the scientific designs of solar salt works and brine managements. Also through the chemical interventions, good quality salt, which is suitable directly to the industrial uses, have been produced. Nowadays, lot of industries, chloral clay and soda ash, they use sophisticated membranes where trace metal impurities are not required. Institute has developed very good technology to produce good. The salt can be directly utilized for chloral clay manufacture. Other technologies are through the brine purification and brine crystal habit modifications. So all these technologies have been covered by either Indian patents, US or European patents, and are in being practiced into the Indian salt scenario as well as abroad. Another point in sustainability of solar salt manufacturing is good quality washing the salt, because salt after harvesting is washed to remove the impurities. The institute has defined or devised several methods, whether these are manual or mechanical, where this washing losses can be reduced. And the capability of designing of solar salt washery is another mastery of CSIR, CSIR, where we can do economic viability after the solar salt production. And that is very rich with marine chemicals, for example, potassium chemicals and magnesium. This is low sodium salt technology. The prominent the potassium, which is in bittern itself, is utilized for making low sodium salt. World Health Organization has given a recommendation of 5 gram daily uptake of salt. But in India and even in other countries, people consume lot of salt, maybe more than 10 grams, double the recommendation of World Health Organization, and it is creating lot of problems to the human health. So such kind of salt which can be directly produced into the solar salt works can be a great revolution and is a great innovation of CSIR, CSIR over the years. Again, the challenging problem in solar salt manufacturing and sustainability poses to the human health is microplastics in salt, because seawater is the raw material and all the water bodies are coming to ocean, and that has been used for manufacturing of solar salt. And how to make salt free from microplastics, which is creating a lot of human issues. So the institute has come about with very advanced technologies wherein we can remove 99% of the microplastics, and salt is free from these. It's a very environmental and health friendly salt is being produced in CSIR farming. And as I told in my first slide, the sustainability can be brought through improving the yield of the salt also, because land uses have to be reduced. Solar salt manufacturing activity is a land consuming activity. I would say a lot of land is being required for manufacture of salt. How to reduce the land and improve the salt yield is again a challenge to the solar salt industries, which institute has tackled in a nice manner. Institute has developed several technologies for rate to increase the salt yield, as well as making pans which are percolation free, and improving the yield through utilization of various industrial effluents. For example, RO and desalination plant results. So it is making sustainable both water industry as well as salt manufacturing industry by utilization of RO reject waters in solar salt plants. And institute has patented technologies to utilize these kind of effluents and technologies have been transferred to the leading Indian and industries and global industries. The institute has so far a very good international and national collaboration and has provided technical services around the globe. Currently, institute is working with several African countries, for example, Senegal, Zambia, Botswana, and Middle East countries, Iran, Philippines, Oman, Saudi Arabia. So institute has spread his wings in solar salt manufacturing and utilization of marine resources for the recovery of different critical minerals and other useful salts used for fertilizers or magnesium chemicals. Institute is helping different countries and is open to work with anyone who is working on salt manufacturing. Thank you for patient listening and open for questions.
Thank you, sir. We'll be taking the questions in the end. So, thank you, sir, for sharing salt scenario, India's emerging position, solar salt technologies, especially yield and quality improvement aspects, then seawater as a source of various marine chemicals, and specialty salt like low sodium salt technologies. And it's good to learn that we are having already global partnership in the utilization of seawater toward salt and marine chemicals. Now I will invite our next speaker, Mr. Bharat Rawal. Mr. Bharat Rawal is the president of Indian Salt Manufacturers Association. As our session chair emphasized that he is having more than 38 years of experience in the salt and marine chemicals field, and he has worked in various big industries like Aditya Birla Group, GHCL, DCW, Nirma, etc. Today, Mr. Bharat Rawal will give an outlook of Indian salt industry and its growth.
Good afternoon, everyone. Hope I'm audible.
Yes, sir.
Yeah. Being a president of the Indian Salt Manufacturer Association and having experience in organized sector mainly to operate captive salt field. Here it is a very good opportunity given by the CSIR to give salt industry growth and sustainable development is one of the good opportunity. So next slide, please. Next.
I have moved, sir. It may take a few seconds.
No issue. Yeah. Yeah. The Indian Salt Manufacturer Association basically non-profitable organization who is working for common issues of the salt industry, India level, national and internationally. Our vision is to work for salt industry for the development as well as the common issues pertaining to the rules and regulation and all these things. We are having around 70 members, including the 5 regional associations. This association established before our freedom, 1945, and we are parallelly celebrating our freedom with this length of institute. Next. Next, please. You can see the history of Indian salt industry. It started in 18th century, and in 1922, government allowed to produce and export salt. This word is very important, allowed to. That means earlier this industry was licensees industries, and after 1997 July, the industry becomes de-licensed. So this indicates the growth of salt industry. Parallelly, the industry, salt industry and basic raw material for the caustic chlorine plant as well as soda ash plant. In 1924, the industrial development started when the DCW came into the picture. And thereafter, every 20 years, all the caustic soda plant established. Recently, the RSPL plant came to Gujarat in, I think, 2018 operating. So soda ash is the leading salt consuming sector. Thereafter, caustic soda is also one of the sector. And then other industries, which already explained by Dr. Arvind Kumar, glass industry and water softening, tanning industry, etc. But 50% of the salt is being used for the industrial purpose. Next. %11% is our contribution globally when the production is concerned. So we are at third rank, immediate after US. So this is the global scenario for the salt industry is concerned, and usages is concerned. Edible, we are consuming 30% of the salt. Surprisingly, the export is being boosted during last 2 decades, and it is reached 41%. Earlier, before 2000, the normal or traditional export hardly was 3.6 million tons in 2000, whereas after 25 years, we reached 16 million tons. Next slide. Typically, Indian salt industry compared to the other leading salt manufacturing country, here you can see the structure of salt industry. It is 92% salt industry is being spreaded in unorganized, whereas 8 to 10% hardly organized sector. If you look at this number of units salt producing, more than 12,200 units are small sector. This is the typical, we can say, typical variety of the Indian salt industry. One thing is here, when we think about the modernization, mechanization, and all these things, it is also a bottleneck, size of the unit, size of the salt field. But gradually and year by year, we have resolved that thing, and we are progressing nicely. Worldwide, 3% growth is noticed, whereas Indian salt industry's growth is noticed 4%. So we are higher than the global growth 1% by 1%. Next. Earlier, around 7 to 8 states were producing salt. Now, out of 8 states, because of this climate change, frequent rain, cyclone, and all these things, Calcutta, Odisha, Maharashtra, Karnataka, these 4 states reduced the salt production drastically. And as on date, leading states are only 4 states. That is Gujarat, thereafter Rajasthan, then Tamil Nadu and Andhra Pradesh. Compared to Gujarat and Rajasthan, Tamil Nadu and Andhra Pradesh salt industries always face a natural calamity, cyclone and heavy pre and post rainfall. That is also there for the salt development, salt industrial development in South zone is one of the challenge for us as an industry partner. Next. This is the normal, means traditional journey of salt. Start from the seawater and move to the factory. And another thing is evaporation. That is the brine input of the brine, and we can get the vacuums. Final outcome of utilized salt is this is a normal picture where we can see the traveling. Next. Yes. This is the slide where we can stay for a few moments and think over that. In 2000, the salt industry at a glance, and 2025 at a glance, you can see the drastic scenario change pattern of the utilization of the salt in edible sector. Earlier in India, we have utilized the Badagra salt, crystal salt directly, and whereas after 2000, means after I think in 1982, when first vacuum salt plant at Tata Chemical, and thereafter another refinery came into the picture. But after 2000, number of salt refinery for the edible increased from 6 number to 46 numbers. So this is the means utilization of the table salt is being growth is very good. Second is quality. When Dr. Arvind Kumar already said the quality of salt for the industry, when we are year by year, we are using membrane cell for the caustic chlorine plant, Zen 5, Zen 6, Zen 7, and nowadays somewhere at Zen 8 also, where the sulfate content within the salt is very crucial, which should be expected at least on and around 0.16% of the sulfate industrial salt. And you can see the growth of quality even. In 2000, our normal sulfate content, we acceptable level also 0.160. And as on today, we can able to produce having a sulfate 0.18 is a tremendous progress for quality is concerned. And we can say, means we are having a proud for that. We can compete nowadays Australian salt also. Salt export is concerned, again, the growth seems tremendous, 3.6. Previous slide, please, madam. Previous one. Here, salt export 3.6 million ton to 16 million ton is also a good. This is also a commercial area where I have touched. The market price is also good after 25 years, but not it is that much. But for industrial salt is concerned, definitely it is a competitive market. So this is overall growth of the Indian is remarkable. During the COVID, it was a glut in the market, but now you can see from this graph glut in the market. But now you can see from this graph steady growth. Steady growth is identical growth for the export. Next. Weather. Now, challenges of the salt industry, salt yield is concerned. Because of this climate change, frequent cyclone, as well as intensity of the rain and number of rainy days increase drastically. So this become a challenge, how to increase the yield in this adverse situation of the lesser the evaporation, higher the rainy days, when we are getting the lower side of the harvesting number of days. Typically at South Gujarat and Bhavnagar, people are getting very few days for the harvesting of the salt. So this overall, the climate change is the coming out as one of the challenge. Next. You can observe this weather impact, temperature, the relative humidity, then rainfall. Rainfall is increasing normal 550 to 800 mm. Number of rainy days earlier 17 to 28 days. Minimum start from the 28 days and maximum up to 45 days. 310 days available for the salt season. It's reduced by 30 days. Means direct loss of 1 month salt production appears over here. Evaporation rate is also because of the wind direction from sea to land increase. Salt yield 66 to 52. You can see because of it is directly related with the cultivated land. the land is increasing doubles, whereas yield is not that much. So utilization of the land by increasing the yield is only the remedy for the growth, further growth at same rate, whether it is a 4% or we can target it as a 6% as parallel to the chloralkali industry. Because of the chloralkali industry's growth is notice 6.2% per annum. So CSM now here, CS collaboration with the CSM CRI can having a reach experience, these two area, they can help to the salt industry. Next. This is a very good collaboration, ISMA and CSM CRIs. We are trying to develop our new generation by giving coaching to them at institute itself. Since last 5 years, we are regularly conduct a program, and it is thanks goes to team CSM CRI, Dr. Kanan and Dr. Arvind Kumar and everyone, and ISMA. And for information, on our ISMA's board, there is a permanent space for the CSM CRI. We are proud for that. And we hope for the better future and prospect and sustainable growth for the salt industry by this collaboration and technology transfer even. Gender inclusiveness and knowledge exchange platform is already there. We are able to provide a very good conference every 3 years or every 2 years to the industry of Indian salt industry as well as internationally. So this journey, ISMA and CSM CRI is remarkable in past, and for better future, I wish good progress and sustainable growth for the salt industry. Next. Next, please. The way forward for the strengthened partnership with the stakeholder worldwide, which I have already explained. The skillful workforce is one of the area considering the growth of salt industry is crucial for this. And for that sustainable growth, we can develop Indian salt industry and keep, I think we can across after 5 years, what I see is we will equivalent to US, definitely. Next. These are the main area we can focus. At last, thanks to CSM CRI and thanks to ISMA also, who gave this opportunity to represent the growth of salt industry, as well as I'm very much thankful to the organization for whom I served for 38 years. Thank you. Thanks a lot.
Thank you, sir, for sharing the history of Indian salt industry, the global salt scenario, industry structure growth, and ISMA and CSIR, CSMCRI's collaborative efforts towards skill development, technology interventions, as well as taking the industry forward to make it further second ranking. So thank you very much for your talk. With this, our technical talks are come to an end. So, session chair, sir, director, sir, I will just check the chat box. If we have any questions, particularly toward our speakers, and if so, I'll be taking them one by one. Yeah, so some of the people are appreciating the session. Yeah, and giving their introduction. Yes, so mostly I can see various industry partner and people like Rani Tech, CETP. All right. So there is a question from Dr. D. Mohan. He is asking how to recycle the used membranes. So I would request Dr. Poyam Singh if and Mr. Nirjar, Dr. Poyam Singh, if you can add something here.
Professor Mohan, I think he's on alumni, the CSIR, I think. And yeah, actually, there are different types of membrane. I would like to know what kind of membrane you're talking about. For example, if you have, we have a seawater RO or a British water RO, or is it hollow fiber? So if we have rejuvenation facility. This is for seawater RO membrane elements. So we can rejuvenate and we can reuse it. And if it is something pertaining to hollow fiber, I think Mr. Nirjar can give a short reply. Over to you, Nirjar.
Nirjarji, please unmute yourself. You are on mute.
Okay, so basically, recycling of hollow fiber membrane is a relatively new idea, and we are working on the lines of converting the polymer that is used for making the membranes into a new membrane feeding feedstock. Our initial discussion with CSM CRI have indicated that it is a viable line of action, but more work will be done. But definitely reusing all the polymers, whether it is PES, PVDF, PEN, all those again as a useful feedstock for hollow fibers is one important line through which we want to recycle the membranes. But still, the study is to be done on the impact of those fibers and the quality of those fibers made from used membranes. So that is one area which will need certain study. But yes, we are very keen on moving in this line because the used membrane will be one of the key major issues which will be there once this membrane's life is over. And we have been facing, or we have been asked this from not only Indian clients but clients outside India also, of what to do of these membranes. So this is one important area of research that we will be working on. But converting them into useful feedstock is one line of action that we will be working on.
Thank you, Mr. Nirjar. Thank you, Dr. Puyam. There is another question that is, what are the prevalent diseases in seaweeds, from Dr. Namisha Sharma. So maybe Dr. Vaibhav, can you please?
Yeah. So, Namisha, there are several diseases of seaweeds reported throughout the world, but if we look at Indian scenario, if you remember the graph which I have shown, production graph, in 2013-14, there was a huge decline, and in fact, entire population of cultivated crop of cover ficus was wiped out. And this has happened because one of the very well-known disease called ice disease. This is a disease very common to several countries like Philippines, Indonesia, where large-scale commercial cultivation is happening. And this is one of the disease not only uh, 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 you know issue for Kappa ficus, but for Gracilaria also. And then there are certain epiphytic diseases also. They are called epiphytic infestation. So as far as your question is concerned, these are some of the diseases which are bothering to our country. We have been working on how to address it. And if you remember my slide and Mr. Tanmay's slide, we have talked about elite germplasm production. So we are basically trying to work on production of elite germplasm. We have developed certain technologies, and also through biotechnological interventions like colloid manipulations, etc. We are trying to develop a new germplasm as well. Thank you.
Sir, there is another question from Niyam Dave, which is again asked to you, Dr. Mantri. Is it sustainable to produce biofuel from marine microalgae in terms of cultivation costing and requirement of chemical pre-treatment extraction process for large-scale industrial application?
See, there are several research articles available. You can go through it. What we understand, our institute also worked on this in the past. you have to quickly understand one very simple logic. As I said, these seaweeds are utilized either for edible purpose and for extraction of hydrocolloids. So if you see the cost of 1 kg of this product, and if you see the cost of 1 kg or 1 liter of your biofuel, you yourself will get an answer. So basically, you can look at to all these articles, and I think you will get an answer. Thank you.
Thank you, sir. There are mostly best wishes and appreciation about the session. There is one important comment from Larissa Ferroni. I'm sorry if I am reading your name wrongly. From IAI and DF, and she mentions that congratulations to all for the insightful and inspiring presentations. The Belmont Forum has just launched the Oceans 2 CRA, a unique opportunity to co-develop and co-implement multilateral projects on shared ocean challenges, including marine resources, blue economy, marine biodiversity, and beyond. Hope to see India engaged. So I would request our chair, Dr. Kannan, if he wants to give some reply to her or on our behalf.
I will tell at the end. I will tell at the end. You can. There is one more question. Is there? There's one more question. Is there for Mr. Bharat Rawal?
Where's okay? Yes, yes. All right. The question is from Pankti Jo for Mr. Bharat Rawal. Salt season has reduced and so is salt yield. What kind of research are expected in future to meet these challenges? Rawal sir, please.
Yes. See, basically, salt season reduced. Earlier, we are getting 10 month out of 12 month. Nowadays, hardly we are getting maximum 8 to 9 month. And in some of the region in Gujarat also reducing because of the pre and post storage of the and storm water management will be the crucial area where we can think over it. Because of the rainwater purging, we never think about it. Now time has come, we can think over it. We can increase the yield by immediate purging and maximize the evaporation rate, where the CSIR has suggested different methodology to increase the evaporation rate. That is the third area we can utilize the instrumentation and R&D is there. So overall, we have to achieve 65 to 70 ton average yield in this scenario, only have a steady growth for the future.
Thank you, sir. There is a question from Akhil EJ, which maybe Dr. Arvind may answer. He asked, iodine deficiency persists in some regions. What are the most effective strategies for ensuring universal access to adequately iodized salt, especially among hard-to-reach populations?
Actually, iodine deficiency is, it's a good challenge actually, and government has tackled it very well also. Government has made a universal iodization for edible salt. India has, there is no salt, for edible purpose which is without iodine right now. I don't see any salt which is in market which is without iodine. So we need to increase the awareness because methods are already available for iodization. We can stabilize iodine, not only iodine and salt with other micronutrients. For example, iron and other micronutrients Institute has developed very good technologies. They are in market and are being utilized by the Indian population.
Thank you, sir. There is another question from Mr. Tamim. Salt washery. Using the mechanized method, losses increases to about 20% from less than 10% if using hand method. So is there any improvement in technology to reduce loss through mechanized washing?
Yeah, this again because the mechanical washing is through the washeries. Those design of washeries is very important. The institute has, depending upon the contamination, basically the salt contamination, and seawater has a more or less unique contamination, but the salt produced from subsoil brines, it is contaminated. It has imbalanced sulfate content, calcium content, and magnesium content, and then the method for washing has to be evolved depending upon the quality or nature of the salt. And institute has technologies. Basically, we have improvised certain methods which can be utilized to reduce washing losses. Maybe 10 to 15% at least we can do it.
Okay. Shriram Engineering is asking to Nirjay Bhatt sir to inquire about applicability of hollow fiber. So since I have connection numbers of contact of you both, Shriram, Mr. Bala, I can connect you to Mr. Nirjay Bhatt, and you can have elaborated the discussion around that, along with our membrane MSST division head. So I'll be connecting you. In view of time limitation, can I now request session chair to kindly provide his concluding remarks?
Yeah, thank you. Thank you, Parul. I mean, I think we have overshot our time. Okay, we are supposed to finish it by 4:15, and my session was to be given sometime, I mean, close to 16, and we are 16:37, 37 minutes overshot. Okay, so that's okay, fine. I think that shows amount of the passion my speakers had in this session. Okay, I mean, everybody, what do you call, but very, very passionate about the work that they have presented. And I mean, I think overall, if you really see, I don't want to get into, although I've written so many remarks for my concluding, but it will be further delaying the whole, what do you call, process. But if you broadly take a few contours, the thing that something which is we have to be very what do you call beautifully thought. Okay, I mean, where there is a kind of an industry or an association who is basically leveraging with the R&D institute and then demonstrating the progress. Okay, demonstrating the progress in the domains that they work. And all of them, I mean, have echoed a few very, very critical things. Namely, I mean, the partnership, the togetherness, the engagement of the research and development institution are something which is extremely, extremely valued and critically, what do you call, and critical, and has been very deeply appreciated by all the industry fraternity. That's really very heartening to, what do you call, note. And if I see almost all the speakers have emphasized on the sustainable development in whatever they do, whether it is on making a kind of energy efficient water purification technologies or the science-backed society engaged Seaweed development domain, or in terms of newer technologies for with a kind of a consistent challenges of climate change and very stagnant land allotment for the salt cultivation. The progress that we have demonstrated in terms of the productivity, I mean, if you really see in the last 25 years, the productivity has gone up by several folds. And the area that has basically gone up is only a couple of a few times. So if you really see, I mean, there's a kind of a technological interventions have started happening in the last 25 years extensively. Technology, I mean, challenges are basically being posed by climate change, rainfall patterns, purity and consistency, demand supply shortfalls between the major industries of the salt users and the salt producing entities. These are some of the very hard pressing challenges where, I mean, R&D intervention, I mean, that is very beautifully asked by some of the people who have been associated in the session also. And these are some of the challenges that R&D institution and industry should work together to solve it. As I said, I mean, sustainable development goal is not a kind of a particular place to reach. It's not that. I mean, these goals are continuously going to be dynamic. Okay, continuously going to be dynamic. So that, I mean, the sustainability index will be continuously on the upward front. Okay, and that's how, I mean, they will be basically positioned. Okay, I mean, if I were to put a kind of a simple question, I mean, within the kind of a sustainable way of doing it, can we basically make a kind of a climate resilient, what do you call, soil productivity practices? Can we basically make a kind of a disease tolerant seaweeds through biotechnological means? Or can we make a kind of a ultra energy efficient membranes with a kind of an what do you call amazing amount of auto cleaning or non what do you call contaminating membrane surfaces through a very delicate surface engineering. These are some of the big challenges that I mean science and technology only can give, and these are some of the areas that R&D institutions should be working in consonance with what do you call the industry fraternity. And I'm very happy that this session has provided a kind of an opportunity for that also. And there has been a kind of an invite from the Belmont Forum also for the calls that they have opened to contribute on the blue economy and the ocean marine resources domain. I think those who are interested, please, I mean, there's a link has also been provided and you can go through that link and then see whether we can join hands. And in fact, I mean, if you really see many on all the three domains, whether it is on salt or whether it is on seaweeds or whether it is on water, as an institute, I mean, we have spread our arms internationally. We have, I mean, deployed plants internationally. We have conducted international, what do you call, conferences on seaweeds, where I mean, several countries have participated. And of late, we have been, what do you call, supporting several countries to realize their dreams of producing salt for their own nations, which is currently, I mean, which they are currently not having it. They are 100% importing it. In our case, the export has increased in the last 25 years. As Mr. Bharat has said, in many countries, I mean, the salt is more than 90% of the salt, which is used for edible consumption, is also imported. So those countries has a dream of making indigenous salt manufacturing, where, I mean, CSIR has been, what do you call, providing, which means, I mean, sustainable development goal is not for one nation. And that's why it is called as UNGA 80, where many countries have to basically grow together through science and technology intervention. And this science summit has basically provided a kind of an opportunity. And I take this occasion, those who have joined on the call, they can always write to me or Dr. Rama Bansal, who is the head of ISTAD at CSIR, that is the International Scientific Directorate of Science and Technology Directorate of CSIR. You can write to her or to me for any kind of an assistance in the domains that we discussed on marine resources. We'll be very happy to help in this journey. And together, I mean, we'll make this planet as a sustainable one. And I thank all the speakers for providing these beautiful insights, which has also been appreciated by many in the session. And I mean, I think such kind of what do you call, international events, joining many people. I'm sure that I don't have a time to say about what kind of a success stories these kind of an international events are creating for many other countries also. And I have hundreds of examples to share on some other occasions. So probably, I mean, I invite you on the invite you to the institute as a kind of a personal invitation as a director of this institute. I mean, those who have not visited this institute, you can visit the institute for overseeing the kind of R&D on the marine resources that we have been doing it. If you are in India, or if you are, I mean, close by to Gujarat, you can drop a mail to me or to any of the scientists who have basically participated. All their email addresses are available in the website of the institute. And I look forward to such greater interactions in the future, which will make our planet a sustainable one. Thank you very much for this opportunity. And I think Dr. Rama has joined on this call. If Dr. Rama wants to say something, she can make a remark before we conclude it.
Thank you, sir. Dr. Rama wanted to say wholehearted thank you to CSMCRI for organizing this wonderful session and the interaction and the wonderful interactions that we had today. She also wanted to thank the organizing committee of SSCUNGA for giving this platform to CSIR for presenting the various developments. And with this, we once again thank all the audience for participating and posing such wonderful interactions and questions. And looking forward to you joining us for the next session that is scheduled tomorrow and day after tomorrow, same time. And best wishes to one and all. Thank you.
Thank you, Team Staff. Now I will request our Business Development and Information Management Head, Dr. Kamlesh Prasad, to formally cast the vote of thanks.
Okay, thank you, Parul. First of all, I would like to thank the organizers of Science Summit for providing CSIR opportunity to present our sessions during the Science Summit in virtual mode. Then I'm also thankful to Pilar Gomez, who is a communication manager and Science Summit project director, for assisting and guiding throughout the process, online session and production, everything. And I'm also very much grateful to CSIR START, Dr. Ramaswamy Bansal and his entire team, her entire team, for coordinating the entire activity and conceptualize the CSIR for connect, collaborate, and coverage, and for global sustainable development. And I'm really very much thankful to Director CSMCRI to envisage the session marine resources for sustainable development and chair the session today for his insightful and while concluding this session. So I'm thankful to him very much. And CSMCRI speakers, my colleagues, Dr. Puem Singh, Dr. Vaibhav Mantri, Dr. Arvind Kumar, for their engaging and insightful talks. And industry partners, Mr. Nirjar Bhatt, Mr. Tanmay Seth, and Mr. Bharat Rawal, for their kind cooperation to become a part of this session and sharing their experiences and collaboration with CSMCRI. CSMCRI's Dr. Adimurthy, who is the head of our STAG, International Science and Technology Affair Group, for his guidance and support during this session, and convener Dr. Paralso, of course, and IT support to assist with the IT support during the online session, and all participants from India and abroad who has joined this session and encouraged us to conclude the session. Thank you very much to all of you. Thank you.
Thank you, sir. With the session chair's permission, we close the session.
Yes, I think we can.
Thank you. The session is closed. Thank you, everyone.
Yeah, bye.